take a network break. I'm Drew Conry Murray.
I'm Jonna Johnson, and we're going to beat back the fall chill with a fresh, hot virtual donut as we talk about the Amazon Web Services outage, new startups taking on incumbent switch vendors and Broadcom, enterprise 5G, small modular nuclear reactors, because why not, Google's latest advancement in quantum computing, and more.
We are sponsored today by Meter. Meter delivers full-stack networking infrastructure from wired to wireless to cellular in a single integrated solution that scales from branch offices, warehouses, and large campuses to data centers. Go to meter.com/networkbreak and book a demo now. That's meter.com/networkbreak to book a demo. Or you can check out the Packet Pushers YouTube channel where Ethan Banks actually runs through some lab equipment that Meter sent him if you want to see that. And also, stick around after the news. We have a Tech Bites from sponsor Equinix. Networks play a crucial role in AI infrastructure, whether to support huge file transfers to a compute cluster, stream telemetry from edge locations to feed AI pipelines, or provide high-speed, low-latency connectivity for AI agents. On the Tech Bites program, we talk with sponsor Equinix about why the network might be the most underestimated piece of your AI strategy and how thinking beyond traditional cloud or on-prem deployments could unlock new possibilities. It's a fun conversation, so stick around for that. Jonna, we got some red alert before we hit the news.
We do. And for those of you desk jockeys who have ever dreamed about hacking the employer who is monitoring your every keystroke, somebody did exactly that.
Ooh.
Some context. Last week, there were 925 CVEs created in the week ending in October 23rd, and 3,602 were updated. Of those, 938 were ranked as critical with a CVSS score of 9 or more, and 204 scored 10 out of 10. This week's red alert goes to CVE 2025 10640, a login bypass for the WorkExaminer Professional Console. WorkExaminer is an application that employers use to monitor the activities of employees, often, but not exclusively, in call centers and contact centers. The CVE details the fact that an attacker with access to TCP port 12306 can gain access to the admin console without authenticating. The root cause is a failure on the server side to pay attention to the values returned by the piece of the login process that actually checks for login validity. There isn't a fix. So the only mitigation is to lock down access to the TCP port in question. So those of you whose environments are being run by that, if you are unethical, feel free. Lots of links in the show notes. I just think that one was a little bit funnier. It's not your usual. So there you go.
It's not. And I guess on the one hand, we shouldn't be encouraging listeners to launch cyber attacks. But yeah, things like WorkExaminer kind of bug me. So
yeah, exactly. Exactly. I agree.
Tool. Yeah. So
exactly.
Hard line to walk. But yeah, don't commit crimes. That's our stance.
Don't commit crimes. Yes.
That's our official stance. All right,
okay.
Jonna, yeah, let's dive in. I'm sure folks are expecting us to talk about this, the giant AWS outage.
Yep. And so just for some background, in case people have been too busy living it to remember exactly what happened, at 12:11 a.m. Pacific on October 20th, Amazon reported it was, quote unquote, investigating increased error rates and latencies for multiple AWS services in the U.S. East 1 region. Over the next 12 hours, a cascading series of service failures plagued Amazon services in that region, generating performance degradations and outages at sites including Amazon.com, Lambda, CloudWatch, DynamoDB, Alexa, Prime Video, and Ring, as well as a lot of major non-Amazon services like Snapchat, Coinbase, Robinhood, Hulu, Perplexity, and Roblox. The outages also generated a series of really gut-bustingly funny T-shirts, which we'll get to in a second. Because the root cause was, wait for it, folks, we all know this, but just saying it officially, a DNS problem. Specifically, a problem involving DNS resolution with the DynamoDB API endpoint. Starting with that, Amazon's identity and access management and other services in the region driven by DynamoDB started to fail. After about 5 hours, engineers thought they had the DNS problem fixed, but the cascade continued to ripple out through the network through network load balancing and EC2 launch services. And ultimately, full restoration of services took 15 hours and 12 minutes, although many services came back online before restoration. Drew, your thoughts?
So obviously this is not great, and the fact that it's DNS probably made a lot of people's eyes roll. But you sort of looked at the LinkedIn responses and the social media responses, and a lot of finger wagging and stuff about like, don't have all your stuff in one region. And yeah, that's true. My first thought though is, and I'm stealing this from a post I saw by Forrest Brazil, namely that if everyone's down, it doesn't really matter. So maybe you lost some business, but so did your competitors. It's kind of a wash. If you did manage to stay up, maybe your customers and partners are down, so it still doesn't really matter. And here's a quote from that Forrest post, which we'll link in the show notes. Quote, AWS has become too big for you to avoid failing, meaning that regardless of what you were doing, an AWS failure somewhere is likely going to have an impact on you. I think that's an interesting take worth thinking about. Another thing
I've heard this referred to as snow days on the internet, right? Like sometimes things just get, if everybody's locked inside because of the snow,
right.
wow.
And I think some days we all do need a snow day. So why not, capitalism will survive if we're all offline for a couple hours. Speaking of that, I feel like, you can design your cloud services to not be reliant on a single region or a single cloud provider, but that does come with some cost and complexity. And maybe it's a strategic choice to not bear that cost and complexity. And maybe instead of dumping a lot of money and employee time and effort into making your AWS bulletproof, maybe you want to spend that money and employee time on other things. Be sure you have a plan for when US 1 East fails. But if it's a strategic decision, I think you could potentially justify being like, we know the risks, we're taking them because X, Y, Z. And Jana, you're more at the strategic level. What do you think about that?
Absolutely, and I'm going to go way back in history to when AT&T was rolling out this brand new service called Frame Relay.
Wow.
And okay. So when they rolled out Frame Relay, they also rolled out a Frame Relay backup service. And I spent hours and hours and hours telling clients, look at the backup service and make a decision. And sure enough, they had an outage because, engineers were dinking around on the production network, and don't do that, guys. And they did, and there was a crash. And basically, I had three categories of customers. The customers who had looked at the backup service said, that's too expensive from us, and let's figure out workarounds. And I'll quote my favorite in a second. The second group, and they were fine. They were like, hey, boss, we made this decision together. We were going to figure out a workaround. Here we go. We're deploying our workaround. We're off to the races. The second group decided that they were going to protect some or all of their sites, and they didn't have an outage, and they were happy. The only unhappy group were the people that just never confronted it and got yelled at because they never thought of it. My favorite workaround, by the way, just tells you how far back in the day this was. This was point of sale transactions for grocery stores, and they basically made this. Their workaround was this. If the network fails, any check under $100 can go through without verification because, we don't care. And I was just like, they paid with checks. Wow.
That is a callback.
It is.
You also mentioned some funny T-shirts.
Of course, now you're going to ask me which ones they are. And, my favorite was, it's a DNS thing you wouldn't understand, but there's also plenty of references to that particular US East 1 region because apparently it has been problematic.
Of course.
And there've been a couple of other ones. Good heavens. I'll dig up a few more. But the T-shirts came out, I think, faster than the outage was resolved.
Assuming you could get to your favorite T-shirt maker online. One last point I want to make regarding, deciding that you are going to live with the potential of outages. I feel like that doesn't apply for absolutely critical things like, medical devices or air traffic control systems or 911 or whatever. So that point is not valid. If we're talking about things that could affect human lives, you do need to plan for outages at US East.
Yeah, and you should plan to spend money on that. Yes.
Yeah, absolutely.
So, okay.
All right, links in the show notes. Moving on, there's a new Ethernet switch startup called Aria Networks. It's looking to capitalize on the AI infrastructure build-out. Aria Networks is building and selling data center Ethernet switches aimed at neoclouds and other big players building out AI infrastructure, in particular scale-out infrastructure. Aria switches are built on merchant silicon, specifically Tomahawk 5 ASICs, and they're running the open source Sonic Network OS with a few additions of their own. Aria is hoping to differentiate by taking advantage of the microsecond telemetry that Tomahawk 5s can produce. I talked with the startup. I talked with the founder, Mansoor Karam. He didn't provide much detail, but the idea is to collect, analyze, and react to the telemetry to ensure the network provides the highest possible performance for AI workloads running across that scale-out Ethernet network. In addition to the switches, so Aria is also going to sell a server and a cloud service, and that's presumably where the analytics are going to. John, any thoughts before I continue?
Yeah, I'm still struggling to articulate what the unique selling proposition is.
The value prop, yeah.
Yeah. Can you maybe clarify that, or is it just this is a hot space, this is a startup in that space?
Well, that's one thing, that it's a hot space. there's some market research from Delora that says just the AI Ethernet infrastructure data center switch market could hit $30 billion over the next 4 years. So a decent sized pie that Aria is hoping to get a slice of. But it's really about, Aria says, the telemetry. We can do things using this telemetry that we're collecting that other folks may not be, other switch vendors may not be collecting and analyzing. We're going to bring AI to it. We're going to bring our expertise in networks to help these neo cloud operators who are essentially renting you GPUs. And these things are so expensive and these workloads are so latency and packet loss sensitive that if the network is slow for any reason, it messes up the neo cloud's business and irritates customers. So the value prop here is we're going to do such cool things with this microsecond telemetry that we're going to be able to deliver the highest performing networks for these neo clouds. That's the value prop.
I'm not being skeptical. I'm being thoughtful. How's that? That's
Absolutely.
A thoughtful silence, not a skeptical one. Yeah.
I think that is entirely, valid. Yeah, for sure.
I would say, so to answer your question, I would say I really want to hear better marketing from these guys because the logic is not wrong, but it's also not incredibly compelling. So, yeah, we should see. I do like the name, though, that said.
Yes, it is a musical reference, and that's. I wrote a blog post about it. If you want the few more details that I could extract from them, it's in the blog post. It's just interesting to see that this AI infrastructure market is so frothy that somebody's going to come at this with a telemetry angle. I think that's interesting. Sticking with AI infrastructure startups, there's a new company called Upscale AI, and they're announcing a new ASIC, which they're calling Skyhammer, and the idea is to provide, quote, deterministic latency, extreme bandwidth, and predictable performance at scale. This is for scale-up networks, not scale-out networks. Scale-up network fabrics are essentially the network fabric within a single pod or rack of GPUs, and in this case, Upscale says it can work with up to 72 GPUs in a pod or a rack. So rather than repurposing existing merchant silicon that's built for more traditional scale-out networks, the startup says its custom ASIC is purpose-built for this specifically this scale-up use case. The ASIC is going to support the UA-Link protocol. UA-Link's a multi-vendor open standard developed by AMD, Broadcom, and others. And essentially, it's a counter to NVIDIA's NVLink. The new ASIC is also going to support ESUN. John, we talked about this last week.
Yep,
ESUN's a new initiative from the Open Compute Project. It's building on Ethernet as a network fabric, again, for the scale-up use case, meaning within a single rack or pod as opposed to scale-out across multiple racks or pods. One thing that I thought was interesting about this, one, obviously it's very bold to come in and try to challenge, Broadcom in the ASIC space. So that's pretty ambitious. The new ASIC is not going to support NVIDIA's NVLink, which means that Upscale AI can't sell this ASIC to folks using clusters with NVIDIA GPUs. So that does seem like a potential limitation. That said, we've seen AMD and others really pushing their own GPUs out onto the market. So I assume there is a market there for them to go after.
Yeah, and I think also that there's probably strategic positioning on their part, aside from the fact that they're a startup that can't do everything. So what do you leave out?
Right.
I think the decision here really is we do not want to be pushed into competing on price. Because if you do what NVIDIA does, then why? I mean, I know they will claim they do more, but if you support NVIDIA, then why, why
Sure.
do they need
Yep.
you? Whereas
Right.
they can compete on they can compete on value with the other folks playing in the standard space, just as we've seen with every form of standard. So I think that's probably a canny, good marketing move on their part. And again, it's quite interesting that this, AI infrastructure space in the other dimension, up not out, is growing. So yeah, worth knowing.
Links in the show notes.
Okay, moving on to sort of more traditional telecom. T-Mobile is now unveiling Edge Control and T-Platform for enterprises. T-Mobile, which has long been known as primarily a consumer service, has been making a concentrated push to go after enterprises for several years, and it's ramping up its 5G telecommunications efforts with a new addition to its advanced networking services portfolio. Its new Edge Control service allows customers to deploy private 5G connectivity on premises and have device traffic bound for local services stay on premise via local breakout functionality. In other words, the traffic never hits the T-Mobile customer edge or core, which means the customer is responsible for all of that traffic and all the infrastructure supporting it. The targeted use cases include sites with tight data locality requirements, interesting thought, sites with ultra-low latency requirements for device-to-server communications, financial services springs to mind, but there are plenty of others. AI and IoT are also there. And in fact, another use case is IoT devices talking to edge compute nodes, assisting with real-time control. T-Platform is the new unified management portal for all T-Mobile business servers, including edge control. So there you go.
Yeah, I'm curious. I feel vendors have been pushing at enterprise 5G, and it seems like if you're trying to compete with like Wi-Fi for just providing connectivity at the office, I don't know how much leg room or interest there is in enterprise 5G, but for manufacturing, warehousing, other places where you're doing IoT and OT, it seems like there's maybe an opportunity there. And if for whatever reason you can't, that data has to stay within a confined location, can't go out to a broader service where potentially there are security compliance issues, that seems like an interesting take.
I agree.
All right, we'll pause for a quick word from sponsor Meter. Meter's delivering full stack networking, wired, wireless, and cellular to leading enterprises. It's a single integrated solution with everything included, and that means everything. They do ISP procurement, security, routers, switches, wireless APs, firewalls, cellular, power, DNS security, VPN, SD-WAN, and multi-site workflows. Meter has designed its own hardware, written the firmware, and built the software, so it is a truly integrated solution. And alongside their partners, Meter designs, deploys, and manages everything required at your site or sites so that you get performant, reliable, and secure connectivity. If you're ready for fast, secure, and scalable connectivity without the complexity of managing multiple providers or tools, it's time to check out Meter. Go to meter.com/networkbreak where you can book a demo now. That's meter.com/networkbreak. Network Break is all one word to book that demo. And we thank Meter for being a sponsor.
All right. And moving right along, Extreme is adding a new service agent to Extreme Platform One. Extreme has announced that its new Extreme Service Agent, named Extreme Service Agent, which is probably very descriptive, has been added to the Extreme Platform One and rolled out to all customers. The Service Agent is a purpose-built AI agent trained for enterprise networking duties. Extreme claims it can automate routine workflows and take on time-consuming tasks like evidence collection, ticket creation, and case management. It says the Service Agent slashes a network staff's manual efforts by up to 95%. No word how much on average as opposed to the up to part, but one can see the value of this. I'm not going to nitpick the statistics. So, yeah, I'm not sure what else to say on this one. Drew, maybe you have some thoughts?
Nothing other than, it's AI, agentic AI and AI agents to help you with sort of day-to-day tasks are being rolled out across the networking universe. So Extreme is also on top of this. So not a surprise.
Pretty much. It's yet another one, but that doesn't make it bad or redundant. It's necessary, useful, and good.
Yeah, I think the trick is vendors are going to have to build up trust with their network engineering customers on the reliability of these tools, given that it's probably backed by an LLM. These tend to be non-deterministic, which can lead to interesting results that may or may not be accurate. So that's the thing you have to watch out for.
Yep.
Moving on, Amazon has announced a partnership with the U.S. state of Washington to build a small modular reactor or SMR facility to provide new electrical generating capacity into the region's electrical grid. And obviously, some of that power will then be used to power Amazon data centers. Amazon says it's working with Energy Northwest. This is a utility company in Washington state, as well as a company called X Energy. X Energy is going to be the one that actually builds and operates the SMRs. The facility is going to be located outside Richland, Washington, near an existing generating station. If you read the release from Amazon, there's really not a lot of detail in the announcement, nor a clear timeline about when these SMRs will be built or operated. The Register reports the construction won't start for another 5 years, with operations beginning in the 2030s, partly because there are regulatory hurdles to overcome, including approval from the U.S. Nuclear Regulatory Commission. I like the idea of SMRs, particularly as we are seeing essentially data centers really start to gobble up electricity that could be used for other things. It's causing concerns about, costs going up for ratepayers, about a lack of capacity, about the money that needs to be spent to build out new generating capacity. If SMRs can actually play a role, I'm for it. But again, here in the US in particular, there's sort of like there's bad vibes, bad feelings about nuclear. John, do you have thoughts about that?
Well, the one thing is that timeline, if it's true, is going to run into kind of a surprise hitch, which is at our conference last week or the week before last, we had a lovely lab tour where virtual lab tour where we went into Columbia's Fusion Center and looked at 2 or 3 different flavors of Fusion machines there. And one of the things we asked not the PI, but the lead researcher, graduate student, was his estimate as to when this stuff would become commercial. And he didn't miss a beat. He turned and said to all of us, "Oh, about 2030." Even if he's exaggerated, I mean, the fact is they're actually seeing, they're crossing the hurdle of getting more energy out than they put in, and they're starting to do it on sustained levels. So, but if he's even close to right, we're going to see an interesting smackdown between modular fission reactors and emerging fusion reactors going forward.
Yeah, I don't know enough about physics to have an opinion here. I do feel like that I've heard about fusion for a long time. It seems like it's taken a long time to get anywhere, but now there are really significant market forces creating a demand for, the research and investment and money to maybe move this forward. We need everything in the mix. So if it turns out to be fusion and fusion eventually knocks nuclear off the table, I guess I don't have a problem with that. I don't really know what the downsides are potentially of fusion, though.
Fusion does have a waste disposal problem, which is not the same scale or danger as fission does. It's also untried, so God knows something could explode and send boiling water all over the place. Boiling water, not good as we know, but certainly not as bad as, something radioactive.
Right.
It's kind of fun, just a side note, because I thought it was fascinating. We all think about fusion. Well, when we do, we think about them as tokamaks, which are those, big toroidal ring thingamies. There's also something else called a stellarator, which is basically kind of a much more new age rubber bandy look. It looks like 2 rubber bands interlinked in a chain kind of look. And when we asked the Columbia graduate student to succinctly explain the pros and cons, he did a brilliant job, because he basically said, tokamaks are easy to build and hard to maintain. Stellarators are hard to build and easy to maintain. And I won't derail us by talking about why, but the fact that there are multiple different technologies out there always gives me an enormous boost of confidence in any sort of broad space. You've heard me talk about how the fact that we have 7 or 8 different flavors of qubits makes me very confident in quantum computing. Well, I'm starting to see the same thing in fusion. So that's what I figured I'd just note. That would be my takeaway on this.
This might be the first time we've actually mentioned fusion on Network Break, so
it won't be the last.
On the list. Maybe it won't be the last.
Yes, it will not be the last.
If you have opinions on fusion versus fission for generating electricity, hit us up, packetpushers.net/fu. Who knows who's out there listening? Maybe we got some fusion scientists. Johnny, you've got some more news from Versa.
I do. I skipped right ahead because I was looking at the Google Quantum thing. I was like so eager to get into it. I did. I'm so sorry. So Versa is integrating with Microsoft Entra. We're Versa is thrilled to announce the native integration of Versa Secure SD-WAN with Microsoft Entra Internet Access. The joint solution delivers what Versa calls a complete SASE architecture. I always hate when vendors say complete, but okay. That converges identity-driven security using, one of the premier owners of identity, Microsoft, so that's a good thing, with application-aware networking to deliver zero trust enforcement, optimized SaaS performance, and seamless management from a unified framework. With the integration, Versa users can enforce Microsoft Entra conditional access and adaptive risk policies across SaaS platforms, private data connections, and other internet apps with continuous, and this is important, validation for users, devices, and applications. Why is continuous important? Because if something is hijacked in the middle of a session, or if for various reasons, maybe the nature of the application has changed or the nature of the process has changed, you want to be able to shut off access to somebody, this is a good thing. Versus SD-WAN can also steer traffic directly to Microsoft 365 and other SaaS applications with no backhaul needed. Again, just improves performance, and can combine QoS, traffic steering, and SLA routing with Entra's identity security controls. Versa can now combine its own telemetry with Microsoft Entra security logs to provide better visibility into path selection, risk assessment, and device posture management. We have a link down below. This, again, falls into the category of great stuff. It's been happening with different vendors over the years. It's a good thing to see.
Yeah, the SD-WAN, the SASE market is heating up, so everybody's jockeying to have the most completest solution. And if you're going to do anything regarding zero trust, you do need an identity component. That's one of the essential components. So it makes perfect sense that they would tie into Microsoft Entra. I think it's a good idea.
Yeah, and before we jump to the quantum and the rest of the show, I just want to highlight the fact that when I stressed the continuous validation, that turns out to be a selection criterion everyone should use for SASE and for SD-WAN, because basically the use case that I've heard about is, for example, a remote user has administrative authority over troubleshooting a user problem for a significant application. That you may want that that administrative access to be valid only as long as the trouble ticket itself is not yet cleared. So something, that's a very concrete example, and you think, yeah, that's exactly what I would want. I would want that thing shut off automatically, so we don't have to remember to shut it off and leave a door open downstream. Not necessarily saying that the person that's doing the help is going to be a problem, but his or her account could get hacked downstream, and you want it shut off. So anyway, that's why I stressed it. That's a classic example of why such things matter.
That is interesting, although the tangle of API calls needed to make that happen just makes me a little dizzy. But
well, that's where zero trust ends up being incredibly flexible, because it's designed for that. But different conversation, just raising it.
Yes. All right, moving on. We have teased this a little bit already. We'll dive in. Google says has developed a quantum algorithm that demonstrates a verifiable quantum advantage. That is, when a quantum computer can solve a problem more efficiently, more accurately, or in a more cost-effective way than a classical computer. So in a paper published in the science journal Nature, Google says it used an out-of-order time correlator algorithm, which Google is calling quantum echoes, which is much cooler than out-of-order time correlator. To compute the structure of a molecule, Google claims it ran this algorithm on its Willow quantum chip, and that it performed 13,000 times faster than a classical algorithm on a supercomputer. Google says it also ran an experiment in partnership with UC Berkeley to study two molecules using this quantum echo algorithm. It also studied the same two molecules using a nuclear magnetic resonance machine. It's essentially like an MRI, but it acts at the molecular level. Google says the results of its quantum computation match the results produced by the NMR, calling this a, quote, crucial validation of our approach. Got a bunch of links in the show notes, but Jana, reading all this, I feel like I need either a PhD in physics or chemistry, or maybe both, to really understand what's happening here. But short answer is Google saying we have a validated quantum advantage here.
Yeah, and of course, on the show, we always try to sort of provide a balanced, both sides kind of view. The only negative I can say, so I'll lead with the positive. Google, great freaking job. Fantastic, very much as expected, and hats off to the folks particularly who said, oh, by the way, we have validated it using NMR, so not only is it a whole heck of a lot faster, but it's actually right. So this is the holy grail of the way computing algorithms should be done. I wish the people over in AI would pay attention to this, but never mind. They at least validated it using the physical universe. This is great stuff. This is the first. Well, I won't say the first of many. This is one of many, and the sort of slow initial popcorn popping of these examples is going to start cascading very, very soon. And this is why we've been talking about it. Is there a negative? The only negative is that Google is kind of casting this. They don't say it, but it sort of reads like this is the first time there's ever been a validated quantum advantage problem. Yes, possibly by depending on your definition of validated, but quite frankly, there are examples of quantum advantage problems showing up. This is just a particularly good one and particularly well fleshed out. So yay, Google.
Yeah. So lots of links in the show notes. Again, a lot of the technical and scientific detail if you want to dig in. Again, we're interested in quantum, and we'll keep an eye on this. We'll wrap up with some financial results from Nokia and Intel. First, Nokia reported their results for Q3 2025. Net sales were 4.8 billion euros, up 12% year over year. Profits came in at 80 million euros, down 54% versus this time last year. By business unit, optical networks were a bright spot. Sales were up 114% over this time last year. Fixed networks were up 3%. IP networks revenue was down 1% year over year. Regarding IP networks, Nokia did say it saw strong growth in North America as well as growth in AI and cloud. Last but not least, Intel reported its Q3 2025 financial results. Revenues were $13.7 billion, up 3% year over year. The company actually squeaked out some net income, bringing in $4.1 billion. This time last year, the company had lost $16 billion. Before you break out the confetti, though, there are mitigating factors in that net income result, including a $5.7 billion infusion from the U.S. government during that quarter. Looking at business units, Intel's client biz was up 5%, data center and AI was down 1%, and its foundry business brought in $4.2 billion, down 2% versus last year. So scoring a profit is nice. Intel's structural challenges persist, so a good quarter, but it's still got a tough road ahead of it. Any thoughts, Jonna?
The only thing is, I'm not sure that the infusion from the U.S. government should count towards revenue. I didn't actually check out whether they were counting it that way, and I am not a financial analyst and don't play one on TV, so I'm always endlessly confused.
That's a good point. Yes,
but I would say, nonetheless, the fact that it hasn't maybe officially passed over into profitable territory still doesn't negate the fact that it is doing a whole boatload better than it was. The only thing that I'm worrying about here, I think they're going very much on the right path, and this validates that, but I am worried about the foundry business being lower. I'm not sure if that was just a little bit of, hey, we're not paying attention to this right now because we're focusing more on the client business, or if there's some real softness out there, something we should know. Something we should watch. Yeah.
We should watch. Yes, and we will be keeping an eye on Intel. All right, that does wrap up the news. Thanks to our sponsor, Meter, and please do stay tuned for our Tech Bytes conversation with Equinix on the role of co-location services in AI infrastructure networking. That's coming right up. AI infrastructure conversations tend to be dominated by GPUs, data center buildouts, and power and water consumption, but networks also play a crucial role, whether you're supporting huge file transfers to a compute cluster, streaming telemetry from edge locations to feed AI pipelines, or providing high-speed, low-latency connectivity for AI agents. On today's Tech Bytes, we talk with sponsor Equinix about why the network might be the most underestimated piece of your AI strategy and how to think beyond traditional cloud or on-prem deployments to unlock new possibilities. I'm Drew Conry-Murray with my co-host Ethan Banks. Our guest is Kevin Egan, Senior Director, Strategic Initiatives Group at Equinix. So Kevin, welcome to the podcast, and I'm sure most of our listeners are familiar with Equinix, but for those who aren't, can you give us the nickel tour?
Yeah, thanks, Drew. So Equinix is a global infrastructure company, a data center company. We are in 76 markets in 36 countries, 6 continents. We have almost 300 data centers globally and are providing, our 10,000 plus customers with the infrastructure needed to do workloads that power everything from AI to mining to networking and service provider, you name it. We're the fabric that runs and enables the world to kind of move forward. So that's a little bit about Equinix. We've got a 99.999% uptime in many of our data centers and are headed towards almost 100% renewable energy coverage in 2030. So we've got a lot of great sustainability goals in front of us, and that's a little bit about Equinix.
Okay, well, that's going to be key. I'm glad to hear about the sustainability, especially given our topic today, AI. So what's Equinix's view on the AI infrastructure landscape? What kind of trends are you seeing affect the networking side of infrastructure in particular?
Yeah, absolutely. I mean, we're kind of seeing 4 major trends develop. First, workloads are really being pushed to the edge. And this distribution of workloads is kind of being driven by smaller, more domain-specific language models, right? This versus purpose-built, general, huge language models like OpenAI. We're getting more vertical or a healthcare or a telco or certain specific industry-specific models are getting smarter and smarter. And so this smaller language model with more specific data is really built to support those edge workloads as they're coming in for certain inferencing type workloads like robotics or manufacturing or automotive, self-driving. All of those things are kind of being framed with these smaller language models. The other thing that's happening is really agentic workflows. Agentic AI is taking advantage of not only these smaller models, not only these edge use cases like inferencing, but also the new technology. MCP is kind of the new API. MCP plus frameworks and blueprints. If you look at NVIDIA, they talk a lot about their framework, their software. They really want to be a platform player, not a hardware specific, vendor. And so that is really kind of driving a lot of creativity and a lot of distribution of AI versus the AI factory mindset, which is still pretty prevalent for those workloads that need the high horsepower centralized location.
You're saying MCP means that jobs and workloads and data and workflows could be running anywhere.
Well, MCP means that those workloads are able to be more flexible. So with that type of framework, it allows you to choose different models based on the use cases more seamlessly.
Mhm.
So think of it like instead of that API type technology, using your agents with an MCP server, for example, you can then access different models, test different models, get different results with different models. And we see this with all the blueprints. Everybody's coming out with blueprints. Those blueprints, like NVIDIA blueprints, or I could name half a dozen vendors, including GSIs, who all have their own blueprints. But these blueprints really allow that flexibility to say, okay, Drew, your business really needs to take advantage of this smaller language model. We're going to use today. We're going to try it with Google Gemini, tomorrow with an OpenAI, tomorrow with a Lambda, tomorrow with and we're going to get the best results for the most cost-effective results and the fastest results too. Because if you're getting an 100 billion parameter model, it's not going to be very speedy, for example. So yeah, so that architecture, that MCPs and the blueprints being driven by that distributed type of architecture is really allowing flexibility, is what I would say.
So we talked about workloads moving to the edge, the rise of small language models, agentic AI, and MCP. What is the fourth major trend that you're seeing?
Yeah, so really it's the kind of the rise of neo clouds and the rise of what we call sort of AI service providers. So obviously the clouds have an easy button set of services for a lot of, really in particular generative AI use cases. But, like an AWS Bedrock and they've got pre-built use cases for those customers. But with the rise of neo clouds and GPU as a service, really being able to provide, more scale to more customers, especially as the GPU scarcities and sort of who's got power, who can allocate and do those type of things, being able to turn those on and off, like we always heard in private cloud, right? You want that cloud-like experience to be able to try, only pay for what you consume, right? So now it's a similar thing happening with GPU as a service, and the neo clouds kind of providing that AI that you consume, and in this case, GPUs. So we're seeing a lot of those specialized AI service providers, we'll call them, and that list is growing, and they have some pretty specific needs that kind of tie into the big picture as well.
Well, Kevin, how do you guys fit into that? Because you're not a hyperscaler, Equinix is not a neo cloud, et cetera. So how do you fit into this picture?
Yeah, it's a great question. Thanks, Ethan. It's like, what we've been talking about with our analysts is, hey, we're the third option. Not only could you do this on-prem, could you potentially do this at the edge, but you could do this in the cloud and choose your cloud service provider. We're the third option, which would be that co-location. And what makes us unique is that we kind of sit between your on-prem or edge and the clouds. We have that interconnected fabric, so we can directly connect you to those cloud service providers, to those network service providers, and now to the AI service providers and the neo clouds. So we've got a layer 2 fabric. We call it Equinix Fabric. It's a software-defined fabric, and it really allows you to kind of do that direct, private, secure, very high-speed access to your other set of providers, cloud, network, and AI providers.
That is, you're the transport that interconnects me to all of the different, wherever it is that I might be running my AI workloads, you can get me there the most quickly with the lowest latency and so on.
Yeah, it's set up for this AI world, right, Ethan, where high speed, low latency, and secure connections to those providers really can mean faster results, better customer experience, all of those things, and allow that massive transport of data between those different locations, whether it's transporting between cloud and your private data set or edge locations and your private data set. Yep.
What are you seeing with this edge use case and how it's tied into this notion of distributed AI infrastructure?
Yeah, so what's really cool is the edge is getting more and more powerful based on, some of those trends we talked about earlier. And with the edge getting more powerful, that really it's a data issue. Data, it means more data is being utilized at the edge, being crunched at the edge, being, for AI and inferencing type of workloads, that's happening at the edge. And that requires a very different type of workload, right? So your east-west versus north-south really comes into play, and having that low latency. So here's an example, right, Drew? If I draw a line from our DC data center, from Canada all the way to Miami, we can get you sub 10 millisecond latencies in that entire eastern geo. Same thing from a Santa Clara data center, right? North all the way to south, we get that. So what's happening is we're calling a metro edge. We have customers who are taking advantage, collecting data at those edges. If you think of like almost an SD-WAN type of topology, they can now have very, very powerful, have the ability to move massive amounts of data in and out of the edge. And you don't necessarily have this one core location where everything has to spawn from. You actually have very powerful metro locations all over the globe. And so for customers, especially that have a golden triangle, you've got London, you've got Dallas, you've got Tokyo. Now you can actually have that directly connected and move data around the world as well.
So that's the transport side. Are folks also thinking about co-location in terms of I need some compute resources in specific locations?
Yeah, absolutely. I mean, we've got a customer right now that, for example, they've got a core superpod running many GPUs, crunching massive model training, and they have that inside of Equinix because they want that privacy, that intellectual privacy protection of their model. They don't want to share that model with the cloud, for example. But then they also have edge inferencing, smaller like H100 clusters at the edge, so that they're closer to where they're collecting those data sets in those regions, that they can run inferencing workloads at the edge. And they're able to move that data back and forth from their core to the edge, for example. So,
but it's not just performance, and it's not just keeping your data set out of the big cloud providers. It's that what you just told me. I heard data governance. So if I got compliance issues and concerns, I can meet those concerns.
100%, Ethan. We say privacy, but really what privacy means is regulated industry, first and foremost. It means intellectual property protection, like that customer example I shared. And then it also means locality, residency, sovereignty. So you have customer data in Canada, for example, it has to remain in Canada, due to those compliance things. Absolutely, you need a global strategy. And so those are the type of enterprise customers that really take advantage of that co-location. Yep.
Okay, well, you said enterprise customers. Give me an example of the kind of organizations that should be thinking about colo as part of their strategy, rather than basically outsourcing everything.
Yeah, so it's two primary customers. Well, it's more than two, but it's large enterprise that have that global footprint, right? The golden triangle we talked about. They've got data that sits all over the globe. They have major offices in those locations, and they need to move that data and connect that data to securely. The other would be the providers themselves. They're our biggest customers, right? So network service providers, they get the reverse effect by having that high-speed direct private access to enterprise customers. And so we have sort of a magnet model when it comes to NSPs and CSPs. If I want to move that data in and out securely from cloud or from network providers, and now AI providers like neoclouds, that magnet strategy is also there.
That is, a neocloud is interested in peering with Equinix because a lot of their customers are going to be peered with Equinix too. So it makes sense. They're now close to where that data is that they want to ingest and process.
Absolutely, that's right. Yeah, and it's more than just neoclouds, because there's a whole class of AI service providers that are beyond just SaaS providers, right? SaaS providers, they run in and out of the cloud, and obviously we all take advantage of those every day, the SaaS clouds. Neoclouds, primarily means GPU as a service, but then there's new classes of AI service providers who are also providing, different services that need that high speed and private connection as well, so they can do things much more quickly, including hardware.
So I feel like our modern networks seem pretty robust. They're delivering voice and video traffic pretty reliably. We saw through the pandemic that, even with folks being all over the place, working from home and so on, the network did pretty well. And of course, traditional business apps and e-commerce are still going on. So are we kind of like in good shape to support AI-driven traffic, or is AI going to introduce new considerations for network engineers that they should be thinking about?
Yeah, there are a lot of studies, Drew, that sort of indicate, okay, if we're close to 50-50 today on data being created by inferencing and model training and tuning, a lot of the projections say that in the next several years, it's going to be 2-to-1, right? Inferencing type workloads, meaning edge workloads, are going to be creating the majority of data. And a lot of the projections say up to 75% of new data being created will come from the edge. And we've been building towards this, right, Drew, with Internet of Things and all the, every smart thing on the planet consuming. Well, now those smart things are like, GPU laden workstations. But you know what I'm saying? I think that absolutely the network has to be able to transport massive amounts of data to and from the edge, and do it securely and do it with very high bandwidth and very low latency. So I think it is evolving the network demands as those use cases continue. And I think agentic and the MCP, the rise of MCP and this ability to switch models quickly and take advantage of smaller models, they're still pretty sizable, right? They still have lots of parameters in order to get the good results. So that data has to be moved around. And so, yeah, I think our networks, while robust, are going to be able to take advantage of new classification of AI driven innovation.
Mm-hmm. You mentioned fabric intelligence at the start of the conversation. Can you give us a little bit of background on what that is and what folks should expect Equinix is providing with that?
Yeah, absolutely. So we rolled out Fabric Intelligence at our AI Summit a few weeks back. And really what this is the concept of making that, in our case, the Equinix Fabric, easier to interact with, more intelligent. It starts with observability and network observability and being able to integrate both directions into your Splunks and your Datadogs and into your Google Cloud monitors and all of your type of tool sets for full stack observability. But then it's also creating that agentic networking assistant where I can ask it, hey, what's the best route to connect between Dallas and London 6, right? And it comes back natural language input, uses that agentic workflow, uses things like generative AI and vector database to kind of come back with, recommendation to say, hey, the best way is for you to use Fabric Edge, for you to connect it in this way. This will give you this specific latency between those two connection points. And that's what we're rolling out with our Fabric Intelligence. And so really kind of interacting with your Fabric, making it easier, making it seamless, making it frictionless, so that you can create that experience and really be able to modify that to your workload rather than the other way around.
So what I'm hearing is, one, there's like a software-defined element or an automated element to make the fabric easier to consume, and there's also, it sounds like you're building an AI front end, an LLM-driven natural language interface for folks to interact with.
Absolutely. And we're actually integrating MCP into the fabric itself. And so we're able to offer those and really kind of support that agentic workflow and the different blueprints that we spoke about earlier, be able to implement those to do any manner of things. But absolutely, the Fabric Intelligence is using that a whole collection of those tools to really interact seamlessly with your fabric and be able to kind of get the best routing and the best connection as fabric becomes more and more part. It's already software defined, Drew, right?
Mm-hmm.
So it's already kind of a layer 2 software defined fabric that connects securely to clouds, to service providers, etc. And now we're just making it easier to interact with that and really more intelligent all the way across the board, and easier to integrate with your favorite full stack observability tools as well.
Well, Kevin, we're out of time. If we've piqued folks' interest in this, where can they get more information about what Equinix is doing for AI infrastructure?
Yeah, absolutely. Go to Equinix.com, look at our distributed AI pages, and we also have a number of blogs that are written around the subject too that I encourage you to go and view as well.
We'll have a bunch of show notes in the link that accompanies this podcast when it comes out. There's all kinds of resources for you, including a solution brief, a deck, and some interesting data from IDC on just how insane this AI build out is going. So make sure to check that out. Thank you, Kevin, for being with us. And thank you, Equinix, for being a sponsor. Sponsors ensure that the Packet Pushers can continue to offer high quality, deeply technical content for your professional development for free. That includes 14 technical podcasts on networking, security, IPv6, DevOps, and more. We've also got an industry blog, 2 weekly newsletters, a community Slack group, a YouTube channel, even an IRC group. You can find it all at packetpushers.net, all free with no login required. You can hear us on Spotify. You can thought lead with us on LinkedIn and rate us on Apple Podcasts. And last but not least, remember that too much networking would never be enough.